hopefully this will tell you everything you really need to know about USB and serial interfaces, not all the technical details of how they work under the covers, but how you can use them. The overview is, I'm just going to talk a little bit about the legacy serial ports that don't seem to exist much anymore, but they sure can still get them on the desktop. USB ports, the adapters that we use now to get our devices to work, the Windows Device Manager, which is key to managing all these serial ports that get created, and also talk about how you can use the USB or serial port to do CW, PTT, and FSK with no external circuits on modern radios, and a little bit about sharing serial ports and sound cards and how to use those. If you do have a question, feel free to unmute and ask in the middle of a slide, or we can get to them at the end. I'll have a Q&A session. So legacy serial ports look like as shown on the bottom here. Let's see if my mouse laser pointer works. This is a serial port. It's usually male on the PC. The older PCs had a male version of the 25-pin connector. By the way, the correct term for these is not DB9, but DE9. The E, the letter, indicates the shell size. This is a big shell. It's a DB shell. And this is a DE shell, and you can have 9 and 15-pin versions of that. Like the VGA connector is a 15-pin version called a DE15. So that's the proper term. Most people still say DB9, but I'm going to try to use DE everywhere. In the old days, life was really simple. A radio had a serial port on it. Some radios still do. Unfortunately, Elecraft and ICOM and Kenwood and Yaesu couldn't agree on what whether to use male or female. In my opinion, the female connector is correct for a device like a modem and therefore a radio. But for whatever reason, Yaesu and Kenwood chose to use male connectors. So if you switch manufacturers, you're going to have to buy a new cable or an adapter. And usually these were on a PC or COM1 or COM2, so real easy. But then they improved our computers and they made all the real serial and parallel ports go away, and they added USB ports. Until recently, radios did still have 9-pin serial ports. Fortunately, the K4 still has one, which is great for interfacing to other hardware. But that's the problem, is the peripherals are still using 9-pin connections. That includes remote rig boxes, many rotator controllers, a step-IR antenna controllers, some band decoders, and amplifiers, of course. Like ACOM and SPE, they want to use serial interface to a radio to get its frequency. So a common solution is to use USB to serial adapters. Briefly, there's essentially two kinds of USB, 2.0 and 3.0. There's also Type C I'm not showing, which is the more modern version that can be connected either direction. But you don't really want to use the blue ones, the USB Type 3.0 on most radios, except for an audio connection. The Type A is on the PC, and the square one, the Type B, is usually on the radio. So there's a lot of variability in USB to serial adapters you can go buy. There's ranking kind of from the best to the worst. Start with the Edge port. I'll show a picture of that later. It's hard to get new. It's very expensive. You can find it used on eBay. Altima is included with microham interfaces. They're also very good and very stable. FTDI, which is what I use in my boxes, is built into Elecraft products and some others. It's very good and stable. For RIDI keying, it does require an extra piece of software, and it is, as I mentioned, used internally by Elecraft. And then Kenwood and ICOM and Yaesu, they chose a different manufacturer, the Silicon Labs. And when you install their device driver, you will see Silicon Labs ports. But the one that you should avoid at all costs is made by Prolific. It's the cheapest one. You can buy it everywhere. If it's a no-name generic from China, it's probably a fake Prolific chip. I strongly recommend you remove that device and try to get an alternative. And the reason for that is, well, I'll go into that later. Here's what the Edge Port 4 looks like, brand new at several $100s and very hard to find. But Edmund's W0YK has been collecting some of these, and if you need one, he may still have some in stock. He sells them for a very reasonable price, or you can find them on eBay once in a while. And the nice thing is that Windows automatically finds it, installs a driver for it. They also make an 8-port version, which is a little more expensive and a little harder to find. I think Ed had a collection of some of these too, W0YK. StarTech came out with a 4-port version that needs power, but the FTDI doesn't. I mean, the edge port doesn't. And it has some little LEDs on it and stuff to tell you what's active on which port, which is kind of nice. They also make an 8-port version, and this you can get easily on Amazon. I get them while you still can, because serial ports are kind of disappearing, and it might be hard to get some of this hardware in the future. Of course, the MicroHam has a whole line of products. The MicroKeyer, this is the MicroKeyer 2R, the MK2R Plus. They also make a different one, the Micro 2R, which doesn't provide interface to a radio serial port, but this one does, actually 2 radios, and it uses the Ultima drivers, and you have to use their custom cables to connect to your transceiver. Here's the FTDI adapters that I recommend. They're easy to find. These prices might be a little out of date now. Everything's going up. But you can buy the FTDI one at Mouser or DigiKey, and the Gizmo you can get on Amazon. Both are great. The nice thing about the Gizmo is it can give you up to 2 or 4 serial ports on one cable. This is the one to avoid. It's sort of a generic look to it. You know, some look like this might be FTDI, but if it's advertised as it has an FTDI chip, you're good. If it doesn't say anything about what chip it uses, it's probably prolific, and I would avoid it. There's many counterfeits of the chip. Their driver will not play well, even when on a proper device, will not play well with other drivers on the system. It fights over the serial ports with other drivers that you may have installed, and it has caused me no end of nightmare trying to debug problems. So uninstall it and throw it away, or put it in the electronic recycle bin. So when you connect the USB to serial adapter, Windows usually locates and installs the appropriate device drivers. If it doesn't, you can always go to the manufacturer website, download the driver. COM port numbers come up kind of sequentially. The biggest number it sees, it adds 1 and gives you a new number. And you can use the Windows Device Manager to change the COM port numbers around. They will change because the Windows thinks it's a brand new device if you connect it to a different USB hub. And most PCs have 2 or 3 internal USB hubs. You're not sure, they don't really label which is which. But like the 3.0 ports will be on one USB hub, and the 2.0 ports will be on another. Maybe if there's one on a monitor, that counts as another USB hub. And so even though the device is the same, if it moves to a different hub, Windows thinks, oh, that's a new device. I need to give it a brand new COM port number. So make a note of where you're connecting your USB cables. Try to always connect it to the same spot, and you won't have your COM port numbers jumping all around. If you have a Yaesu Kenwood ICOM radio, it's very important to install the manufacturer's device driver first before you plug in the USB cable. Most hams just plug everything in and say, why doesn't it work? You have to install a driver first so that it recognizes the new device. There is a way to recover if you do that. It's going to come up in your device manager as unknown device. So you have to uninstall that using device manager, then install the driver, then plug in the cable, and then it'll work. Again, COM port numbers come up sequentially, and they can be changed. So this is a very important part to learn about the Windows Device Manager. There's many ways to start it, and you need to right-click on the Start button and then click Device Manager. That's one way with modern Windows. Or you can hold down the Windows key on your keyboard like a Shift key and tap the letter R for Run, and then just type in devicemanagement.msc, which is the actual name of the program. But before Windows 10, you did have to do one thing first before starting the device manager, and that is set a system environment variable. I think most guys are probably not running Windows 7 anymore, so I'm just going to skip the next slides pretty quickly. But for your reference, there is a set of slides that shows how to set the system environment variable to that value. And you create a new one, and you put in the name and the number 1, and then the device manager will show hidden devices, which is really helpful to see. So that's only required on Windows 7, and at Windows 10 and later, you don't have to do that environment variable anymore. So once you have your device manager open, you always want to do view show hidden devices so you can see all the COM ports, even ones that aren't in use anymore. They'll be grayed out. You see down here at the bottom, that is the that gray symbol there means the device is not connected, and you don't see those unless you say view show hidden devices. So it's very useful when you see COM port number conflicts and stuff is to be able to see that. Now you can right click on any of the ports, even the ones that aren't connected, and you can go to properties, the offline devices, and you can see if it's an FTDI driver. It shows you right there, the driver is FTDI. And if you see prolific here, you want to click this uninstall device button down here and you want to get rid of it. Even if you're not plugging in anymore, you want to get rid of it. You also want to check this box if it's prolific and delete the whole driver, because it's the driver software itself that messes up Windows, not necessarily the driver, even if the device isn't plugged in. So just get rid of all prolific stuff, please. Okay, if it's FTDI, you're good, but there's still another step to do, and that is go to the port settings tab and click advanced. And then this is the default settings for the all FTDI device drivers, including ones from Elecraft when you first get the device plugged in. It is going to check this box that says serial enumerator. That's not good. That's going to make your radio, if you set it up for keying by COM port, key about 4 or 5 times every time you turn on the computer or connect the USB cable. What's that mean, serial enumerator? It means it's looking for a serial mouse. That's for backwards compatibility. When's the last time you saw a mouse with a serial port connected to it? So you want to uncheck that box, and you want to check the box below it that says disable modem control at startup. That's the only box that should be checked on that dialog, and then you want to click OK. And Windows will remember that setting for that COM port number on that device until it does a major refresh of the drivers. Then you got to go back and do it again. But it's important to do this. It does no harm whatsoever. It prevents accidental keying of your radio by connecting a USB cable or turning on the PC. So that's it is also possible to do this on the legacy COM ports. If you're lucky enough to have a PC, a desktop with real serial ports, they can also key your radio. And the only way to prevent that is to go into the registry, as I've indicated here, locate this filter and rename it, and then you won't have any more unwanted keying. So step by step, you can create a restore point if you want to make sure you can get your registry back if you screw something up. And then you want to open up the device manager and look at the details tab and look at this property called device instance path. And that's going to have this long string here that tells you where you're going to locate this COM1 device in the registry. And then you go into the registry under HKey local machine, current control set, and you'll find that key, PNP05010. And there, right there, it says upper filters equals ser enum, where that arrow is. And that's the thing, that's the serial enumerator that's making it key your radio. That's COM1 there. So you rename that to old upper filters, and now it won't run the serial enumerator anymore. And if you want to get it back for some reason, like you found a serial mouse and you want to see if it still works, you can rename it back and you'll be able to go. The other thing you want to do is you want to prevent Windows from powering off your USB hubs, which it tends to do when it thinks there's no activity. That can happen on a rotator, which doesn't generate much traffic. So you want to go to all the USB hubs in the device manager and right click on them and say, do not allow the computer to turn off this device. That box is checked by default for power management. And if you have a power management tab on any of your devices, you want to always uncheck the box. We don't want anything powered off when we're trying to use our radios. There is another tool besides the Windows Device Manager that you may or may not find helpful. It's called the USB Device View program. There may be others. It's a little weird to download it. You go to this website and you have to go all the way down through a bunch of stuff on the page till you finally get down to the download USB DView link at the bottom. Here's a screenshot of what it looks like. It has a useful column over here on the right called the last plug and unplug date, which will give you a hint as to which device it was that I just plugged in. And you can see a lot more detail than you can in Device Manager, but most of it you don't need. You can right click on these devices and do a bunch of actions from here. But easiest way to manage COM port numbers, because they do tend to get bigger and bigger over time and you can't figure out which COM port number is which. And there's some software that won't even support high COM port numbers. They've just improved WinTest. It can go up to COM 32 now. It used to only go to COM 13 or 12. So you can, one suggestion I have is kind of try to number your serial ports in a logical fashion. So you know the left to right, this is COM 1, and the next thing over is COM 2, and so on. But first, what you want to do is get rid of all the serial devices that are grayed out and no longer in use. And then that frees up the COM port number sequence for those, and you can put them in. So right click on the remaining COM ports and change go to the advanced button and set the COM port number. So let's see what that looks like. So here I went to the advanced settings dialog again in the device manager for the COM port. And I see a COM port number, COM 5, and that's where you renumber it under the advanced settings. I can move this device to any other COM port. Make sure no program is using it at the time, otherwise Windows will defer the change until you say you need to reboot for the change to take effect. So you can change COM port numbers if no programs are using them at the time. But what does that in use thing mean? That doesn't mean that a program is openly using it. It means that Windows is using that COM port number. And maybe it was years ago. So you try to reassign something that says this number may be used. Well, it doesn't mean you can't use it. It just, especially for a hidden COM port. So if you uninstall all those grayed out hidden devices first, that'll help. But it's usually safe to ignore this warning. It says this name is being used by their device. And you can click yes when you're renumbering things. I also like to label my serial ports in the device manager. This is something that requires a registry edit, but it's really handy in my case with two K4s and two KPA1500s to try to figure out, which rig is which, because each one supports two COM ports. So I found it very useful to have the names of the devices in my device manager. So once I figured out what COM port was what, which is easy to do by unplugging a cable and plugging it back in and seeing what COM port numbers appear, you can go into the registry. Again, you first look at the properties of the device on the details tab. There's a shortcut when you're in any drop-down box in Windows, especially big long ones like this property box here. Just type the first letter of the thing you're looking for and it jumps to that spot. So I just type the letter D and it jumps right to device instance path and anything that starts with a D. And again, there's this big long string here, so I make a note of it. And then that's what I'm looking for in the registry. So again, under the registry, same key as before. Here's the FTDI bus key with the arrows down here. And there's that big long string that I found, which was the device instance path. And right here, there's a key value that says friendly name. And that'll have the one that Windows puts in by default. In this case, USB serial port COM3. So that you can edit that key and change it, and it'll show up in the device manager. So here I am, just double clicked on the friendly name, or you can go right click and modify. I changed the name. I left the string that was there, and I just added, it's my K4 serial number 73 USB number 1. And if you renumber serial ports, though, Windows is going to change the name back to the default. So you want to do all your renumbering first and then worry about labeling. Sometimes you get in a situation where a program you started, it says serial port in use or cannot open serial port X, and you see it in device manager and everything looks fine, but maybe some background program is running that you can't see, and you want to figure out what program has opened this serial port and why can't I get to it right now? I rebooted and it's still there. So rebooting is the easiest way to make sure nothing's using the serial port, but you never know what a startup folder is going to run. So there is this free tool you can download from the Microsoft site called Process Explorer, and you want to run it as administrator. You right click on it and say run as administrator, and then there's a search button. I'll show you a screenshot in a second that can be used to search for some of these strings. Unfortunately, all the device manufacturers put a different string in, so it can be a little challenging. Here's what I've managed to figure out so far with the various drivers and what they're using. And if you search for that partial string, it'll find the serial port and what program is using it. So here's an example where I hit this yellow icon here, this binoculars for search, and then it pops up what do you want to search for, and I put in device VCP, and it told me, okay, that's WinTest. It's using device VCP0, which is some COM port number. And that I know that I can terminate that process, and I'll have access to the port again. Here's another example where it turned out OmniRig was using the port. OmniRig is a port sharing program that a lot of software like Log4OM and WSJTX can use it, and it can open the serial port too and hold on to it for a little while. It tends to let it go after no programs are running. So what if you don't know what string to search for, but you kind of know one program that uses the COM port and it works okay? There's this funny little icon in Process Explorer that you can actually grab with the mouse and drag on top of an active window, and it'll jump right to that process, tell you all the COM ports it's using. So the trick there is to drag that on top of a window. In this case, I dragged it on top of a program, and then it popped up wintest.exe, and then you go to the view menu. You only have to do this once: view, lower pane view, and handles, and sort by name. You sort by name by clicking on the column title. That's whenever you see a list view in Windows, you can always click the column title and it will sort by that column. And here it is down here. Here are all the devices like keyboard and input, output, and so on. But right here, I can see that it's using this device VCP0. Now I know what to search for to see who else might be using that device. Okay, that's enough about locating serial ports and managing them. Let's talk a little bit about how you can use serial port pins to do CW, RTTY, or push to talk. So this is an ancient circuit that works very well. It's very simple. You don't need anything fancier than this. This is a common method of keying a radio with a COM port pin. So just for those who aren't familiar with what I'm trying to show here, if this DTR pin, which is pin 4 of a serial port, and it can be a virtual one too, if it goes high voltage, it turns on this transistor and that grounds the keying line. And if the pin 7, if it goes high, turns on this transistor and it grounds the PTT line. So that's a way of keying your radio with a voltage. And that's how the serial port keying works. It was also done on printer ports back in the day when we had printer ports. Now, Elecraft was the first manufacturer to add this kind of circuit inside the radio, so you didn't have to build an external circuit to do it. It doesn't use these pins in normal RS-232 handshaking. RTS stands for ready to send, and DTR stands for data terminal ready. Those are handshaking protocols from the old days of slow modems and small buffers when things had to be coordinated between the sender and the receiver. But K3 doesn't use those. Most radios, if they use any handshaking at all, it would be on the RTS pin only. So you can reuse those pins. You just have to set the menu in the K3 to tell it that you want PTT, for example, on the RTS pin and keying on the DTR pin. The default is off. And it works the same over a USB cable as a standard RS-232 cable. You can use either method. You can do very accurate CW and RTTY keying over a USB connection. If you do things properly, as I show later, you won't have any serious timing issues to worry about. But as I mentioned earlier, if you want to prevent unwanted transmissions when your PC reboots or you plug in the cable, you do have to always change those default settings in the device manager, the serial enumerator, and check that disable modem control at startup box. Elecraft K4 has 3 serial ports now, 2 by USB, 1 by RS-232 connector, and they added FSK keying in addition. You couldn't do FSK keying on a K3 by serial port, had to use an accessory connector. So this is a screenshot of the K4 setup menu where you set this, it has 2 serial ports on the USB, PC1 and PC2. Here I've set the DTR pin to do CW and the RTS pin to do PTT on the first serial port. The same serial port being used for read control with the logger. Again, you do need to, because it's FTDI, you do need to check those 2 options in the device manager. I'm going to go through a lot of other radios that have the same feature. ICOM was the next to add it after Elecraft did it. They were first to add FSK. It's supported by all these models. I think I may have some new models now that I haven't listed here, but all their new models support this. But the 7300, which probably a lot of you guys have, it just generates one virtual serial port. So some programs like N3FJP, which wants two different serial ports, one for CW, one for rig control, they can't take advantage of this. But they could take advantage of it on these rigs where the two virtual serial ports are available. And that's why when you open the device manager, you'll see, for example, two Silicon Labs ports or a port A and a port B for the 705. The first one is generally the port that will only work for the logger. The second one won't work for logging. It'll only work for keying purposes. You can use the pins for any purpose, but I'd like to keep it simple. And so I always use the DTR pin for my keying and always use the RTS pin for the push to talk. And the second port can be assigned to MMTTY for FSK RTTY keying. Here's my little cheat for remembering what pin goes to CW and FSK. C, D, and F are all right next to each other in the alphabet. So CW is on the DTR pin, FSK is on the DTR pin. And similarly, RTS is close to PTT or SEND, as some rigs call it. So alphabetically, keep that in mind, and you can remember which pin's DTR and which pin's RTS. One of the tricky things when you plug in an ICOM radio that supports two ports is that usually the lower number is the port A and the secondary number is the higher number is the port B, but not always. Again, you go to your friendly device manager, properties, details, look at that device instance path. And if it ends with the letter A, that tells you that it is the rig control port that you're looking at. In this case, COM5. And it says at the title bar here, COM5. So I'm going to just go through the rest of these kind of briefly. It's more detail about every rig's a little different onto how you tell it. I want to do CW and RTTY keying on the USB cable pins. And in the 7300 menu, it's USB keying CW. And in MMTTY, you have to use this EXT FSK program. It won't work with just telling it to use the COM port 5. But unfortunately, since the 7300 just has one virtual serial port, you can't use your logger at the same time as MMTTY. So my recommendation there is to use an external CT17 or equivalent, which is a USB to CIV cable. Plug that into the remote jack or CIV jack of the rig, and then do rig control there and do your keying on the USB cable and your audio. 705, similar. I guess this says 7610 here. It should say IC 705. Set connectors, USB send keying is a little different menu location. They have the USB A and B, and I do keying of RTTY on B and keying of CW on A. And you have to pick which one you want to do PTT on, the A or the B. Can't unfortunately do it on both like the K4 can. K4 lets you wire in parallel as many RTS keying pins as you want to, but ICOM insists on just one. And then the logging software, you tell it, do CW on the DTR pin and do PTT on the RTS pin. Same story with the EXT FSK. And as I mentioned, you can't use both ports for hardware PTT. So you could do software PTT on one and hardware PTT on the other. I'm just going to skip through the rest of these. They're there for your reference. Similar kind of things, menu settings for the 7610, the 7850, just all little different names. ICOM isn't consistent, but at least they support the feature. The ASU 991 allows it. Had a little struggles with this one. Haven't been able always to get keying on DTR. It seems to insist sometimes on keying on RTS. Don't know why. I think it's a bug in their firmware or some various releases, but it is possible to make it work. FTDX 101 and 101MP, similar story. Kenwood 890 has menus for setting the virtual COM port, PTT, CW keying, and RTTY keying pins. Okay, so how do I get my logger to actually do this CW for my rig once I've got the USB cable connected? Well, you've got your rig control port. If you check the little box that says CW other, you're then allowed to use the DTR and RTS pins for CW and push to talk. You don't need a Win key. You don't need anything fancy to key great CW within 1 mm like some people think in the old days you had to because the timing wasn't good. But that timing problems have all been solved with modern computers and a setting I'm going to show you later. So don't worry about it. This is simpler. One cable for everything. USB, rig controls, CW, audio, it's all there. So all you have to do is tell it, do CW on the DTR pin, do PTT on the RTS pin. No Win key. You don't need to check any of those boxes that say do hardware and software PTT. That just confuses everything. Hardware PTT is the simplest and fastest. It's a lot easier for a radio to go key down when it sees a port closed than to try to process a command and decode it. And it works, but it's just going to be less reliable, and you can get stuck in a key down situation easier if your logger quits after you sent the software command to go into transmit. WinTest has very similar menu settings, very simple. Now here's the rub. If you want your timing to be good, because people are saying, oh, you need a Win key to get decent CW out of a PC because of all the interrupts and stuff. Well, that's kind of nonsense these days. If you have a laptop computer or notebook computer, by default, to save battery life, even when you're plugged in, they change the power mode to balanced or something like that. All you got to do is click on the little battery icon and slide that thing all the way to the right for best performance. Then your CPU won't go to sleep and you won't have weird timing issues. In a desktop PC, they hide this high performance power plan option. You have to go to create a power plan and create it, and just to prevent the CPU from going to sleep. And now you won't have any timing issues. Your PC CPU will be running at max speed. Might get a little warmer though. Balanced is the Windows default. I don't recommend it for when you're doing CW or ready keying on a PC. For ready keying with these USB ports, you generally can't just put in the COM port number. It needs a special extra piece called EXTFSK, which is actually installed with MMTTY now. And you pick that as your port number, and then when you click OK, and also you want to click this radio command button and make sure all these are set to none so it doesn't try to open the COM port of the radio and send PTT commands or initialization commands or something. You just want to make them all blank like this. Then you go over to the miscellaneous tab and you tell it, I'm going to do my my ready keying on the COM port TXD pin. Actually, you get to change it later. We want to click that USB port button, make sure it's set to limiting speed, always for USB ports. And it'll remember those things. And then you tell it which pins you want to do your keying on. No radio that I'm aware of allows FSK keying on a TXD pin. It's only DTR or RTS. I tried to get it in the K4, but they couldn't do it in the end. Some rigs like Yaesu and ICOM, you might have to, Yaesu, you may have to, and maybe Kenwood, you may have to check that invert FSK box down here, because when you ground it, they may shift the wrong direction. You can find out pretty quickly if you're keying upside down just by using the reverse beacon network to see if you're spotted. So what about sharing serial ports, and what if there's conflicts, and how do I get around that problem? Because I want all my programs to talk to the radio at the same time. Well, you can't do it in hardware because there's only, the way these voltages work on serial ports is they go positive or they go negative. And so if you put two lines in parallel, they cancel each other out. So that's like putting two transmitters and keying both at the same time on an antenna. That doesn't work so well. So you don't want to wire two pin 3s or the TXD or transmit data line in parallel. So only one device can connect to pin 3. That's usually a PC. So the PC will poll the radio or send radio commands on the TXD transmit data pin, and the radio will send a response on pin 2, which is the receive data pin. I'm talking about 9-pin serial ports or their virtual equivalent here. Now you can get a radio to automatically send information by turning on its auto info mode. Elecraft lets you do that in a menu. With Kenwood, you have to send it a command, and it tends to reset it as soon as you turn the radio off. But there's a lot of devices like the step-IR controller and the baby loop controller and various band decoders and all these amplifiers that are smart enough to just listen to the RxD line. They don't have to send commands. They will send commands if you want them to, but you don't have to connect pin 3 in those amplifiers. Just connect to pin 2, and as long as a program is running or it's in auto info mode, the amp's going to track okay. To date, RF kit amplifiers require a connection to both pins 2 and 3. They need to send their own polling commands, so they will not automatically track the frequency of a radio unless they're the only thing controlling the radio, or you set up something fancy. I did create, if you'll forgive me, a box to allow this sharing, so you wouldn't have to decode your own Y cables and stuff. I mean, build your own Y cables, which is kind of a pain. I call it the serial box, and there's a USB model with a built-in FTDI chip, and it allows parallel connections to the RxD pin for multiple devices, and also breaks out keying circuits, 4 of them, for FSK and RIDI keying. The transistor is built in for older radios that don't have the capability I talked about earlier, including all the radios listed at the bottom here. None of these radios have built-in keying circuits, so I put it in the serial box, and just a simple RCA cable to your rig will key the radio, or FRIDI or PTT, and I'll provide any cables you need to make that work. So what about sharing serial ports by software? There's a lot of fancy programs for doing this stuff. It usually confuses the heck out of people. The simplest one, in my opinion, is OmniRig software. You tell it the COM port, and then you tell all the other software like WSJT or WriteLog or WinTest or DXlog.net to use OmniRig as the interface, and then it acts as a proper traffic cop. All these programs support it. There's a long list, but there's some very important programs that refuse to support OmniRig, such as N1MM and N3FJP and HRD and some others. So if all the programs are using OmniRig, everything shares great and everything syncs. But if you have a program like N1MM or these others that wants exclusive use of the serial port, this OmniRig is not going to work for you. It acts as a proper traffic cop. There's no collisions or conflicts between the applications. They all think they're talking to a radio, but you don't specify a COM port number. You say use OmniRig. But you can't do this CW, PTT, or FSK type keying through the OmniRig interface on those pins. There's another program out there called N4PY Pegasus Plus. He supports a number of different radios, and he creates virtual serial ports that other applications can use. But again, keying won't work. There's others out there like VSPE and VSP Manager and COM0Com. They all can work, but none of them are really ham radio aware. So you could easily get 2 programs sending commands at the same time, and I think it's just going to intermix the streams. And might work some of the time, but not all of the time. I can't really recommend those, but some people have to use them for flex radios or other radios. But Win4K3 suite or Win4K4 suite or Win4ICOM suite, I think it also supports virtual COM ports like Pegasus Plus does, and it's obviously ham radio aware. There are some radios that have both a USB and a DE9 or legacy RS-232 connector, including the K3 and the FTDX3000, or the K3S and the FTDX3000. But the problem is they do not operate independently. You got to pick one or the other. So in other radios and the newer radios, the serial and a USB port do operate independently. You can set each to a different baud rate. Use one for rig control, one for keying, or one for an amplifier, one for logger. And that includes the Kenwood radios, the K4, the AC radios listed here. And for ICOM, they almost always, except I think in the 705, have a CIV connector, which is an alternate way of communicating with the radio. And most of their ICOMs, except for the oldest ones, do not can operate with both independently, giving you 2 ways to talk to the radio at the same time with 2 different pieces of software, and they each think they own the radio. But you do have to set that menu option to unlink from remote. Remote is the name of the CIV jack. And unlink means make them work independently. Otherwise, they're operating in parallel, which is not what you're after. So it's nice though, but you have 2 devices polling the radio at the same time, perhaps a logger and an amplifier or a step-IR controller, something like that. Well, finally, wrapping it up here, the sound card you get automatically when you plug in a USB cable to a radio is useful for WSJT and other digital modes as well as voice keying. But one of the things you have to remember is the first time you plug in your new USB cable, Windows will make it the default sound card for Windows, and then all your sounds are getting played over the air. You don't want that. So if you want to figure out which device is your radio, right-click on the speaker icon, and then you open the sound settings, and you'll get to the sound, and you want to find the sound control panel. And that's sometimes on the right if your window is narrow. If your monitor is wide, you have to scroll down. I've underlined it in red here. And you want to click on that sound control panel. I think in Windows 11, it's even harder to find. The quickest way to get to it, in my opinion, is just hold down that Windows key like a shift, tap R, and then type in the name of the control panel here, multimediasystem.cpl. That's a multimedia sound control panel. What's the sound control panel? This is the sound control panel. This is our friendly, easy to use interface that we've had around forever, and they've completely buried in Windows 10. But it's the most useful one. This green check mark means what is my default Windows device for recording and what is my default for playback. You want to highlight that and then click the set default button to move the check mark there. When you plug in a new device, it's going to make the new device your default Windows sound card. You don't want that. So how do you figure out which of all these sound cards is my radio? Well, just keep that dialog open, and you'll find one of them disappears when you unplug the USB cable from the radio. It won't go away when you turn the radio off, because power comes from the PC to chips inside the radio. So just turning a rig off generally doesn't make a USB COM port or a virtual sound card USB audio codec go away. You really physically have to disconnect the USB cable from one end or the other. And then you know which device is which. Now, once you figure out, okay, that's my radio, let me label it so I know what it is. So you can actually see under the microphone properties this string here, and you can just double click on it and edit it. And then you click apply, and it's now named that sound card. You can also click the change icon button. I like to make it look like a radio, so I know it's the difference between the mic in my PC and the audio codec, which is the radio. So they give you a little pictures of icons here. We need more icons of real radios, but this one looks close enough. Looks kind of like an IC7300, I guess. So to sum up, the key things that I'd like you to remember from this presentation are always use the Windows Device Manager to manage and renumber your COM ports so they make more sense and there's no gaps. Always uninstall any prolific device drivers or devices and get rid of them. Change the FTDI defaults, especially after a major Windows update, so it doesn't accidentally key your radio anymore. And consider labeling your COM ports as I showed in the registry editor so you know what COM port is what. You don't have to keep referring to your notes. Try this CW, FSK, and PTT keying over the USB cable. It's a lot simpler, a lot less hardware. Just plug paddles into the radio for hand sending and use the computer to generate CW on the USB cable. That applies to CW as well as RIDI. And if there's any conflicts or you don't know who's using a port, you can use Process Explorer and label your sound cards also so you know what's what. So here's some references. There's a link to this presentation on my QRZ.com page. Some other presentations there too. There's where you can download USB DView. I haven't tried these links in a while. I think they're still up to date. And my serial box port sharing interface for and keying interface is available at the link there. And you can always email me at n6tv@arrl.net. So with that, I'll open it up for questions.